Welcome to the first official episode of FAM. So, we have a mission for today, and we will have a mission for every single day we have at Foundations of Excellence in Mathematics. Our mission today is to figure out how to use variables in the real world. So, here we're going to do section 1 for today. We're going to do all 14 problems as per given. So, what I'm actually going to do is I'm going to take a screenshot of that, and I'll explain why later, because we want to be able to draw on this. So, let's see. Let's start with problem number 1. K minus 3 equals 17. We can imagine this as, oh no! You need to get 17. You need to find a certain number to get 17 apples. It looks like you have about 3 more. You need to find the number where you remove 3 to get 17. If you pick the wrong number, you could eventually not get the right amount of oranges, and you could die because there is a very special condition for not having certain vitamin C. So we need to figure out what we have to do. According to this, we have to add 3 to the other side because we have to cancel out the 3. If we add 3, K equals 20, which means that's our answer. Phew, 20 oranges. We saved our lives. That is amazing. Great job. Now let's try this one. We can imagine K over 5 equals negative 2 like this. Oh no! You have to figure out how many groups of negative 2 it will take to get the right amount. However, it's only in pairs of... So actually, let's go ahead and remove this negative sign. So, if I go ahead and do white, and then I can remove this, we can do K over 5 is equal to 2. And then we can add the negative sign back. So let's just say this. Oh no, you only have 2 oranges, and you can only get groups of 5 into the equation. How are you going to do that? When we have a multiplication problem like this, we have to multiply 5. Let me explain why. X times 5 is equal to 5x because any variable times a coefficient would equal 5x. Because if x was, say, 2, we would do times 5 is equal to 10. So with that in mind, if we have x is equal to 2, then it would be 5x because 5 times 2 is 10. But anyways, now we multiply by 5 on both sides. X is equal to 10 because 2 times 5 is 10. Phew. And now, if we add the minus sign back, we get negative 10. Phew. We got the right amount. Great job. Now let's take this scenario. So it's the same thing here. Let's just say this. Oh no, you only have 7 packs of medicine to keep you alive for the next few years. If you pick too much or too little, then you will get serious illnesses and you could potentially not live for any longer. So we need to figure out what we need to do and what we need to solve in order for us to use this for the future. So we must do 7 times 16. And instead of using a calculator, we don't have a calculator. There's no internet. There's no service. There's nothing we can use. We're out in the forest. We'll have to use our mental skills. To do so, we'll use distributive property. Distributive property is basically when you take 10 or 5, because multiplying by 10 and 5 is actually easier than some people think. Multiplying by 10 is adding 1 0 to a number. Since we have 7, it is 70. Nice! We did it. Okay, now we have to do 7 and 5. Now all we have to do is take our number and divide it by 2. And whenever you're dividing a number by 2, it'll either end in 0.0 or 0.5. So since we have 7 and 7 divided by 2, if we take one number lower than that, like 6 divided by 2 is 3. And then since we have 7 over 2, that's just going to be 0.5. So odd numbers will always have a 0.5. And since we have 0.5, we'll have to multiply that by 10, which means moving the decimal point. So if you're not sure what that means, whenever you multiply a number by 10, you move it by one place. Let me show you why. So say we have to add 3.5 10 times, because that's repeated addition, right? Well, if we add that point 10 times, we will get 35. And this is simply because whenever we add a 0.5 that many times, we will get a 0.0 because 5 plus 5 is 10, and that just means adding one more. So if you take 3 plus 1, you'll get 7. And then multiplying it by 5, we'll get 35, because 7 plus 7 plus 7 plus 7 is 35. And as we can see, that's our third number. And we can try this with other numbers too. But for now, we have to add all of these numbers together to get our answer for B. So we add all of these together, and we get, well, let's see here. 0 plus 5 plus 7 is 2. 1 plus 7 plus 3 is 112. Phew, we need 112 packs of medicines. Now, how are we going to afford that? Well, we can figure that out using the number of money we have with this next problem. Oh no, we need to figure out the amount of money we need to get all of those answers. We need to figure out the amount of money we need for that 112. So, let's do, now, when we have multiplication, we have to use division to amplify that. So we have 18 and 18. Now, let's go ahead and take out this negative sign right here. We'll add it back later when it's necessary. And then all we have to do is just divide, and then we add the negative sign back. So 216 divided by 18. Now, most people would pull out their calculator, but again, we have no internet service. We have to figure out how to do this ourselves. So what I like to do is I like to simply use a formula by multiplying 18 using multiplication. So whenever we're dividing, we can also represent this as 216 over 1 divided by 18 over 1. Whenever we divide fractions, we have to move the numerator and denominator in opposite places. So in that case, it would be this. Now let me explain to you why this is 100% correct. So whenever we take multiplying the reciprocal of a number, it essentially means that we're taking 116 multiplying it by 1, and then we get that answer overall. So if we take 216, it'll be 216 over 18, which is the exact same way of saying 216 divided by 18, because these are the same. So now if we take that number, now that we have that for reference, we have 18 times x is equal to 216. So let's start adding 18 here. So 18 plus 18 is 36. And then 36 plus 36 is 72. So that's 2, that's 4. Add this again, and then you just keep adding. So then you do 2 here, and since 36 is 2, you add another 2, which is 4, and then you add another 4, which is 8. What I'm essentially doing is I'm taking the numbers and I'm multiplying it by 2, because if we add the same number, that's multiplying it by 2, because x plus x is the same thing as 2x, because multiplication is repetitive addition. So that's how you explain that. And then we have 4 and 144. And we're getting so close. If we add 144 again, we'll get over 216. So now what do? First, let's understand that 144 is 8. So 144 is 8. Or essentially, it just means that 18 times 8 is 144. And now we have to find the number that will get us to 216. To do so, we'll simply do this and subtract. So we have 2. 11 minus 4 is 7. You take out the 1. And let me explain how that works. So if you take a 100 number here, in this case here, you can add it to a 10, because 11 tens is equal to 110, because 10's place goes over here before the 1's place, whatever that is. In this case, it's 0. So that's how that works. And then you do 1 minus 4, which is 7, and then 1 minus 1 is 0. So that's 72. And we already mentioned that 72 is 4. So that means we have 8 plus 4, because 18 times 8 is 144, and 18 times 4 is 72. So all we have to do is just add it, because we know that 144 and 72 equal 216 because of vice versa and divisibility. So it would be 12. So with that in mind, x is equal to 12, which means that we need to get approximately $12 to afford for all these packs of money. So the answer here is 12, add the negative, and all we have to do is just add the negative sign. A is equal to negative 12. Whew, we saved the day again. Okay, now since we already discussed this over here is going to be optional. So all of this is right here. It's all optional. You don't have to do it, but here at FEM, we want to make sure that it's 4 at max. So, without further ado, I hope you learned something new, and a clear takeaway, here are some things that we learned today. Number 1, moving variables to the other side. Take 17 plus 3 is equal to 20. In a real scenario, say you have a certain amount of oranges, but then you lose 3 and you get 17. So let's just say this little stick figure is us. And we have a mystery number of oranges, but we lose 3. Since we lose 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now imagine this. Do we need to get a certain amount of oranges? Do we need... Oh no, I just lost 3. I have 17 left. But wait a minute. How much do I need to, take home? Because maybe you can only go to the grocery store, once a week, and, there's 7 days in a week, so you eat, maybe with bananas. You eat 2 bananas per day. So, let's just say, it doesn't matter. Well, if you take 17 and then you subtract it by 14, you get 3. And then, if you had 4 siblings, you would not be able to share that with all of them. But if you were careful and understood that you could add 3 back, you could take all those back, and you can get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, then you would have 20. You would eat those for itself. So you would have 14, and then 6. Now you have enough for even 6 siblings to distribute between the rest. And then there's other problems which have division involved. So maybe you're chopping onions and you need to know how many slices you need for 10 siblings. In this case, you would chop it up 10 times, and you would put the negative sign. And negative signs, they can just be used for distances and intractability and construction sites. And then multiplication, that's if you want to multiply by 16 if 16 siblings get 7. But there's a lot more scenarios. This was kind of unrepresentative, but we'll definitely demonstrate a lot more. But anyways, I hope you enjoyed this video, and I will see you all next time. Goodbye.